Hi, I'm Charita K. Reddy, a software developer working on IBM App Connect Enterprise. In this video, I'll demonstrate how to create and deploy RAG flows using ACE patterns. I'll start by opening the patterns gallery in the toolkit and navigating to the RAG pattern, which is available under the AI patterns category. At a high level, the RAG pattern consists of two applications, an indexing flow and a REST API flow for query. Let's first look at the indexing flow. The indexing flow reads plain text files from a directory and splits the data into equal sized chunks with a configurable overlap. Both the chunk size and chunk overlap can be controlled using user-defined properties. These text chunks are then sent to the watsonx AI node which generates embeddings. The generated embeddings are inserted into a Pinecone vector database. Next, let's look at the REST API application, which supports querying. This application exposes a post operation called query, which takes a user question as input. The watsonx AI node generates an embedding for the user query, and this embedding is used to perform a similarity search against the previously created vector database. The text retrieved from the most similar vectors is then combined with the user query to form a final prompt. This prompt is then sent to watsonx AI, which returns the final response. Now that we have covered the architecture, let's start by downloading and installing the pattern. The pattern specification page provides information about the pattern and its flows, along with the detailed instructions for configuration and deployment. Next, I'll create a new pattern instance. This takes us to the pattern parameters page where we configure how the pattern generates resources. In the index input section, the input directory specifies the location of the files you want to index. The file name pattern allows you to filter which files are processed. In the chunking parameters section, we have chunk size and chunk overlap, which I'll leave at their default values. The watsonx AI account details section includes the server URL and project ID. The Pinecone account details section includes the server URL, the index name where embeddings will be stored, and the vector dimension. Once all parameters are configured, we can generate the resources. These generated applications appear in the left panel under Application Development. The next step is to create a local integration server with access to an external directory vault. Please make a note of the vault key specified here as we'll need it later. The integration server has now finished initializing. Before deploying the flows, we need to ensure that the required credentials are available in the credential vault. On the pattern specification page under Setting up Credentials, you'll find the commands needed to create a watsonx AI credential and a Pinecone vector database credential. After running these commands successfully, you should be able to see the credentials in the Integration Explorer. Now let's begin by deploying the application, starting with the indexing application. Before deploying the indexing application, we must first deploy the policy project. Once that's complete, we can go ahead and deploy the indexing application itself. Here, I have a banking compliance policy document that contains information about KYC and AML frameworks. I'm now adding this file to the input directory. Let's open the web UI and review the activity logs. I'll increase the number of entries displayed and refresh the page. Now we can see the entry completed processing file, which confirms that the document has been successfully indexed. Next, let's deploy the query application. The HTTP endpoint is available at localhost on port 7800. I have this chatbot that serves as a simple frontend, allowing us to send questions to the RAG query API endpoint. First, What is the purpose of the bank KYC and AML policy? Here's the response returned by the application. Next, let's try who's responsible for approving the KYC and AML policy. The application correctly responds with the board of directors. Now let's ask a question that's unrelated to banking compliance. Which is the longest river in the world? As expected, the response indicates that the information is not available in the provided data. This confirms that the application answers questions only based on the indexed content. One important point to highlight here is that the index is updated dynamically. If we were to add new documents to the input directory, say something related to geography trivia like the longest river, this will allow the indexing flow to process them and the system will then be able to answer queries based on that new data. This makes the solution flexible and easy to extend without redeploying the application. And that brings us to the end of this demo. Thank you for watching everyone, and I hope you found this helpful.